The focus of this video lesson is finding the geometric mean. The geometric mean of two positive numbers, a and b, is defined as a positive number x that satisfies a over x is equal to x over b. So x squared is equal to a times b, or x is equal to the square root of a times b. So if we want the geometric mean of 24 and 48, we're finding the number x such that 24 over x is equal to x over 48, or x squared is equal to 24 times 48. So we have 24 times 48, 1,152. And then we want to solve for x, so we'll square root both sides of this equation, and x is the square root of 1,152. We'll take a moment to see if this radical can simplify by looking for perfect squares that are factors of this number. So remember our perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, and so on. So let's work our way down this list. So let's start with something small, 4. 4 works. So let's go back and let's try something larger, maybe 16. So 1,152 divided by 16. All right, 16 also works. 1,152 divided by maybe 64. Okay, 64 works. And then let's use 64. So we can see that this is 64 times 18, but we can also see that 18 has a factor that is a perfect square. So this is 64 times 9 times 2. Now, 64 and 9 are both perfect squares, so we'll square root them. The square root of 64 is 8, and the square root of 9 is 3. And 2 is not a perfect square, so it'll stay under the radical sign. We're going to multiply the two numbers that are outside the radical, leaving us with x is equal to 24 times the square root of 2. And that's our geometric mean. All right, now it's your turn to try. Find the geometric mean of 12 and 27. Pause the video, give it a try. Compare your answer with a neighbor to see if you got the same thing. All right, let's see if we can connect that idea to what we've been learning so far about right triangle similarity. In this right triangle, we learned last week, we could see 3 triangles within one picture. Now in this triangle, we can compare this small triangle with this medium triangle. Now on the small triangle, CD is the long leg. And in the larger triangle, AD is the long leg. So we'll write a ratio of long leg over long leg. And then in the small triangle, DB is the short leg. And in the medium triangle, CD is the short leg. So we create a proportion comparing the long legs and the short legs of the small and medium triangle. Now this should look familiar. It should look like a geometric mean, right? CD is our x, x over AD is equal to DB over CD being our x. Through cross multiplication, we get CD squared is equal to AD times DB. And this here leads to our next theorem. Theorem 9.7, the geometric mean altitude theorem. In a right triangle, the altitude of a triangle, that here CD, from the right angle to the hypotenuse, divides the hypotenuse into 2 segments. The length of the altitude is the geometric mean of the lengths of the 2 segments of the hypotenuse. That is, CD squared is equal to AD times BD. So this times itself is equal to this piece times this piece. And then we have theorem 9.8, the geometric mean leg theorem. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. In this case, CD CB squared is equal to DB times this whole length, or AC squared is equal to AD times this whole length. Let's go ahead and try it. So in this case, we're trying to find the altitude, so we're going to be using theorem 9.7. Now we know the altitude times the altitude, or altitude squared, is equal to the one piece of the segment times the other. So we know x squared is equal to 6 times 3. So x squared is equal to 18. Solving for x by square rooting both sides, we get x is equal to the square root of 18. But this can be simplified. 18 is 9 times 2, and the square root of 9 is 3 root 2. All right, let's look at one more. This one, we are trying to find the leg. Now, according to the theorem 9.8, a leg squared is equal to the segment below times the whole thing. So let's do that. So y squared is equal to the other leg connected to it times the whole thing, which in this case is 2 plus 5, or 7. So y squared is equal to 14. Square rooting both sides, y is equal to square root of 14. There are no perfect square factors in 14 since its only factors are 1, 2, and 7, and none of those are perfect squares, so this is our simplified answer. All right, your turn to try. Find the value of x. Note, we're trying to find an altitude. Set it up, pause the video, give it a try, compare your answer with a neighbor to see if you got the same thing. All right, now it's time to do some practice. Complete the right triangle similarity and geometric mean practice. Turn it in when you're done.